Hello, welcome. Today I want to go over learning objective one, Riemann Sum Computation. This is one of the core objectives that will show that might show up on the final as well. This is the foundation of calculus 2 because we know that the definite integral, the main object of study in this class, is the limit of Riemann sums. So understanding Riemann sums is really crucial um, to um, to learn the material of the course. So what is Riemann sums about is estimating the signed area between a function and the x-axis. When the function is above, it's positive, below it's negative. We want to estimate that area. That is the definite integral. So Riemann sums estimate definite integrals. Okay, so, what do you need to be able to do to successfully learn this objective? You need to look at these four bullets and be able to do all those. Now, before we actually do a problem, I want to make sure everybody knows where this learning objectives and questions is located. If you go to home, under important course content, learning objectives and questions, here's that PDF. It has all 16 learning objectives of the course. For the first challenge, you need 1 through 5. So working on the sample questions is crucial to your success in the class here. You definitely want to be spending time each week working on the sample questions for the learning objective covered that week. So at this point in the course, you should definitely have worked on all these sample questions for learning objective one. If you haven't, then you should probably do that before the first challenge attempt. Okay, so in the first sample question, there's a Desmos link, which I always recommend using during the challenge to check your work. This can you if you input the correct function and the endpoints in here, it shows you the sketch of the graph, and it also shows you the answer over here. Um, and this is the exact signed area answer, but this is the approximation you get by the Riemann sum. Okay. So we need to, I want to work specifically on the practice challenge question that you had to do. So that's the express the sign there between x squared minus 4 on this interval using a midpoint with n rectangles. So when you first look at this, you're like, okay, wait, n rectangles. So what is n? um, uh, and could be arbitrary, right? And the reason why we'd want n to be arbitrary is like, say our approximation is not good enough, then we need to increase n. So we want a formula that's flexible so that when you increase n, you're not starting over all over again, but you can just change the n value and you get the new result for the estimation of that signed area. Okay, so but before you get to this point and you're able to write this formula down, you need to have practice and understand how Riemann sums work and midpoint Riemann sums in particular. So let's backtrack and think about, okay, let's make this question a little bit easier. What if n was 4, say, and we want to estimate the Riemann sum? How do we do it with midpoint? Um, Once you solve that, then you can kind of need to try to generalize it. So, okay, going to our Desmos here, we need x squared minus 4 for our function, and the interval from a is -4 to 4. We need 4 rectangles to approximate it. So that means the interval from -4 to 4, which is length 8, is split into 4 equal pieces, and each of those will be 8 divided by 4. It will be length 2. Okay, and each of those on each of those pieces, you're gonna um, write just draw a rectangle that approximates the area on that interval. Okay, so there's different ways to find the height of the rectangle. The three main ones are you pick the left, the right point, or the midpoint, but you can pick anything in between. So if you pick the midpoint, which is what this question is asking, you between -4 and -3. It's -4 and -2 is -3, and you plug that into the function, and you get the height here, which is 5 for the first rectangle. Here, the midpoint is -1, so the height here is -3. Remember, the area below the x-axis counts as negative, so the greens are positive, these are negatives, and we add them all up to estimate the definite integral here. Okay, so let's do it. So we know the answer is supposed to be 8. Okay, so area of a rectangle is base times height, so 2 times what's the height of this first rectangle? We're picking f of -3 will be 5 in this case. We can do that by hand, right? You plug in -3 here, -3 squared is 9, minus 4 is 5. But it's always helpful to have decimals and check, get the values using the graph as well. Sometimes the values are complicated, but we'll see how to deal with that. Okay, so then for the second rectangle, the base is 2, but the height is -3, and we're going to say it's -3. It doesn't make any sense in terms of area, but remember, because it's a signed area, so if it's below the x-axis, it counts as negative. So I'm going to stick with -3 here, and then plus base is 2, and then the height is again -3 for the third rectangle. The last one is 2 times 5. So okay, so we add all those numbers up, we get 8. Great. We approximated the signed area, but now we want to make this more general. Okay, so how do we make this more general and more flexible? So first of all, I want to be able to change my function. Whatever function I got, I want to be able to change it. So I'm gonna rewrite this as a Riemann sum. So a sum of the terms like f of something times the width of the rectangle. So so for the first rectangle, we got, how do you get 5? Well, you plug in -3 into the function, and that gives you 5. Okay, so f of -3 is 5. Okay, but then you multiply that by 2 to get the area of this rectangle, which is 10. And then for the second rectangle, well, what do we plug into the function? We plug in -1, the midpoint between -2 and 0. So f of -1 times 2 plus another rectangle, f of 1 times 2, and lastly f of 3 times 2. Okay. Now this is 8, it all matches up. Great. If I change my function to say x squared, and I wanted to calculate that, the answer is 40, and with my new notation, it really works out to be 40. Okay, great. That added some flexibility. No matter what you get on the challenge, you should be able to do it using this method. Okay, then next, we want to make it even more general. What if there's, instead of 4 rectangles, there's 100 rectangles? Then what do you do? Well, sum will be and I like to generally the indices here of the sum tell you how many terms you're adding and at which term you're at, and you can start counting um, those numbers that you're adding using different indices. The most common one is 1 to whatever n is. In this case, n is 4, so you go 1 through 4. That means we're going to add 4 terms, and they look like f of something times 2, because 2 is the width of each of these terms. So these are each of these rectangles. Okay, so but then how do we change the input into the functions? It's supposed to be the midpoint between this number. See, The output 5, -3, -3, 5, that might be random depending whatever function we got. So that's not the pattern we're seeking here. We're seeking the pattern in the x values that you're going to plug into f of x. So that's -3, -1, 1, and 3. The nice thing about it, because uh, we got equal partition here, equal widths, each of those, there's a pattern. The pattern is like whatever number you start with, you keep adding 2. And 2 is the delta x, because that's what you, to jump from one midpoint to the next, you add 2. Okay, so -3 to -1, and so on. So because we keep adding 2's, 2k definitely needs to be in there, right? Because 2k is saying like, okay, when k is 1, you got 1, 2. When k is 2, you got 2 2's. So you're doing 2 plus 2. K is 3 is 2 plus 2, that's 3 times, right? You keep adding 2. That's what you take the delta x and you multiply by the k. That makes that pattern happen. Now, the starting point, though, see, if I plug in k equal 1 in here, I get 2. 2k, 2 times 1 is 2. But I want my starting point to be at -3. So how do I make that happen? Well, when k is 1, you get 2. So to get to -3, I add -5. So -5 plus 2k. If I start at -5 and I add 2 once, I get to -3, but if I add it twice, add 2 2's, I will get to -1, and so on. So this matches. Okay. Now, because this is, where did the -5 come? Well, it's just -3 minus 2, right? That's -5. Now, but if you want it easier, which I prefer, is go from 0 to 3. Instead of 4, you go 4 minus 1. That's 3. That's still 4 terms you're summing here. K going 0, k is equal to 1, k is equal to 2, and k equal to 3. There's 4 terms, you're summing them up. And but when I start with k equals 0, this 2k is just 0. So I can just put in the starting point, which is -3. And that's easier to me, at least conceptually. Okay. Now, let's say I want to have 100 rectangles. What happens in that case? If I got 100, well, my width is 8, and then the width of each rectangle is 8 divided by 100, right? Because from -4 to 4, that's the width 8, b minus a is 8. And then divided, we're having 100 rectangles. So n is equal to 100 here. Okay, that looks scary, but it looks very accurate. Okay, but then, okay, this is the actual answer. I'm not there yet. What's wrong? Well, because see, I'm still using the old x values here, -3, -1, and so on. But I want to start. Where do I start? Well, let's see. I start on the left. I start at -4. Where's the first midpoint? Well, if you do -4, the first midpoint, you're gonna have to add half of this width of the rectangle. So 800. Half of that's gonna be 4 over 100. So 0.04 you add to -4. That's the first midpoint. And then you're gonna to change from one midpoint to another, you do 8k over 100, right? Because each time when k goes up by 1, you're adding 8 over 100, and that lands you to the next midpoint. So that gets me there, but I'm not done. Notice the answer is wrong. That's because I need here to go from 0 to 99, and now we're done. But now, okay, we want to change it in general for n, so this would be n minus 1. The bottom here will be n, and the bottom here will be n. All the 100s change to n, and I should be done. So now no matter what n you pick, you get the right answer. I say pick n to be 4 again. Answer is still 8, so that matters. And so I solved the question